Hello, my name is Bushra and I'm from DataTalent Program Cohort 17. And today I'm presenting my Capstone project titled Analyzing the Impact of Development Indicators on Carbon Dioxide Emission, a Data Science and Low-Code Approach. This project combines data science techniques and low-code tools to explore how various development indicators relate to carbon dioxide emission across countries. The project falls under the environmental and sustainable development industry. The goal is to understand how development influences carbon emission and to support more informed, sustainable policy making across nations. The objective of this project is to analyze how development indicators affect carbon dioxide emission across countries. I also aimed to identify patterns or clusters among countries and evaluate whether low-code tools like NIME can effectively support this analysis alongside traditional data science methods. The key questions that will be answered in this presentation is which development indicators are more strongly related to carbon dioxide emissions? Then comes the how do countries cluster based on these indicators? Can we predict emissions using selected indicators? And can low-code tools be used to do this effectively? So I use two data sets. First, from the World Bank's development indicators, which includes GDP, electricity access, internet usage, and carbon dioxide metrics. And the second one that I used is from Kaggle that includes sector-wise emissions across countries. I specifically filtered for data from the year 2023 to maintain the consistency for both the data sets. I had to combine the two datasets for the data preparation purposes. This included filtering data for 2023, aligning country names, selecting relevant features, and merging the datasets. The result was a unified dataset that could be used for the meaningful analysis. Data cleaning. Sorry. In the cleaning step, I removed columns with many null values or duplication. I then filled remaining missing values with the median, which helped avoid bias and keep the data consistent. Some of the columns filled included the electricity access, GDP per capita, internet usage, unemployment, and carbon dioxide emissions. In the exploratory data analysis, I started with univariate analysis. For example, both GDP per capita and carbon dioxide emissions per capita were right skewed, as you can see in the graphs, showing that a small number of countries dominated the higher end. On the other hand, most countries had high life expectancy and access to the electricity, showing progress in the basic infrastructure. Next, the bivariate analysis showed that countries with the better digital access, like higher internet usage, also tend to have higher electricity access. These relationships hint at how development can drive emissions. The country level comparison shows that China, the US, India are the top emitters in absolute terms, but on a per capita basis, countries like Qatar and Kuwait are higher, showing the influence of fossil fuel dependency. In contrast, many sub-Saharan African countries rank low in GDP, emissions, and development metrics, highlighting the global inequality. The multivariate analysis um, showed that one group of countries with the higher GDP, high emissions, and strong infrastructure, and another group with the low development and minimal emissions. Population size also played a role in differentiating these clusters. In the advanced exploratory analysis, the pair plot helped confirm strong relationships between GDP per capita, electricity access, and internet usage, all tied to the development. There was also a visible group of countries with both high GDP and high emissions, emphasizing the environmental cost of economic growth. The principal component analysis and k-means clustering was used to reduce dimensionality, and this helped me identify three clear groups of countries based on their development and emission profiles, supporting more targeted comparisons across regions. Then I used the NIME low-code, no-code approach. I also explored this tool using the cleaned data set I built a linear regression model to predict carbon dioxide emissions per capita using features like electricity access, internet usage, unemployment, GDP, and population. This demonstrated how non-programmers can use KNIME for predictive modeling. The results and interpretation included the model achieved an R-square of 0.476, meaning about 48% of the variation in emissions can be explained by the selected development indicators. While this is moderate, it shows these indicators are meaningful and confirms that low-code tools can produce actionable insights. But why R-square is moderate, which is 0.476? The moderate R-square is due to the factors that were not included in the dataset, such as the industrial activity, energy source types, transportation systems, and environmental policies. Also, filling missing values with the median might have reduced the model's predictive power, and linear regression may not fully capture the complexity of these relationships. But how can we improve this model? What I think to improve the model, I would include more relevant features like energy usage by sector and policy indicators. I would also try more advanced algorithms such as random forest or XGBoost. And finally, I would use feature engineering, log transformations, and better data quality to capture non-linear relationships more effectively. Thank you so much. This is my GitHub repository link where this file with all the data sets and Jupyter notebook and KNIME file is available. So you can go and check the link. Thank you so much.